I think this is all relevant, and one of the reasons it's relevant is because there are forces. It's not just, oh, I had a brilliant idea, or I've got an important need. A lot of this stuff is due to social forces. The growth in science after the Second World War, and in particular after the Russians learned Sputnik, was a consequence of a social force. And an awareness of the social forces is sometimes quite appropriate. So I'm saying that there are social forces that make the web browser a platform. And in some senses, a platform is as important as Linux and Mac OS and Windows. And one of the great benefits of the web browser as a platform is that the security model, if you like, is well understood and trusted. And it's pretty much the only software that, in a restricted environment, you can download onto your computer and use. And it is trusted, for example, for banking software. So that's saying there are really powerful forces making the web browser platform, and the scientific notebooks and the scientific publishing and data science are all growing areas. So that from that point of view, I'd say that's the reason why in 25 years' time, TeX will be run in browsers as a mainstream event, as part of the mainstream. And if that sounds unlikely, I've got two things here. The first is MathJax already has that role, and it provides TeX typesetting algorithms for mathematics that's encoded in LaTeX format. So MathJax is, up to a point, LaTeX typesetting of mathematics in the web browser, and that's already in use. It already works, and it's reliable and widely used. The second thing is the performance issue. The performance issue, I think, won't turn out to be that bad. Here's something relevant to that. Around 1985, Commodore introduced a computer called the Amiga, which was very advanced for its time. And it had a Motorola 68000 processor, and it went through a number of iterations. And there are people who really have a strong affection for it, just as some people have strong affections for old cars. You can get emulators for the Commodore Amiga that run on other software. So you're on another piece of software, you're using some other PC, and you can produce an emulator. There's a group that have produced something called PyStorm, which is completely different. It takes an Amiga and you pull out the CPU. Take an Amiga, and a real physical Amiga, and you remove the CPU. Then you put in the PyStorm adapter board, and then the PyStorm adapter board has got a socket into which you can attach a Raspberry Pi. And you've got to remember, Raspberry Pi is an ARM processor, 4 cores running at gigahertz, whereas the 68000 was running at original CPU was running at tens of megahertz. So that that combination of the Pi Storm and the Raspberry Pi pretends to be a Motorola processor. And it can pretend to be a 68,000 if that's what you want, but it can also pretend to be a 68010, 20, 30, 40. And I haven't looked up to find out, but I dare say it can run at all manner of clock speeds as well. So essentially, you've got a CPU from the future running in your hardware.
Yes, it's really gratifying that today on almost any desktop processor, you can run one or more virtual machines that will run a 20 or 30 or 40 or even 50-year-old operating system many times faster than the original hardware. On my office and home machines, I run 75 to 100 virtual machines simultaneously on each of them. And collectively, on other machines, we have more than 500 such things. And they sit there mostly idle, but occasionally they do work for us, like testing software. I'm actually involved this week in testing some anomalies in Motorola 68000 floating point arithmetic. And I've engaged multiple people in this discussion, and it's going to take some days to iron out where the difficulties are.
Is it going to be another Pentium bug?
That's unclear at this point. We're getting results both from physical machines, old Macs that had the 68,000 CPU, from Mac OS, from NetBSD, from Debian Linux, and it's going to take more digging. Results we're getting are inconsistent and puzzling, and we don't understand them yet. But I think in a week or two we'll have sorted it out. This has happened before. Last year, I discovered a bug in the IBM mainframe emulation in QEMU that with a one-line C program, I could crash the virtual machine and destroy critical system files.
Oh, I'm glad
just with a one-line command to compile and run that one-line program. The bug has fortunately been fixed, but I think the remarkable thing is that the emulators really are so good that for the most part, any operating system that ran on that particular hardware, say 30 years ago, will very likely run on the emulator today and run just fine.
So let me return to my theme, which is, does TeX run quick enough most of the time on an ordinary PC today? And the answer is, I think, yes.
Yes, in fact, I can tell you we've done extensive benchmarking of many, many machines over the last 25 plus years of typesetting the TeX book. This is not something you're supposed to do, but it's a throwaway benchmark. And on the fastest machines today, TeX will typeset that very complicated book, which of course is largely devoid of pictures because the artwork that begins each chapter was added by the publisher. But the text itself typesets at 1,500 to 2,000 pages a second. And for comparison, in the early 80s, when we were running TeX on mainframes, you would get 1 or 2, 3 or so pages per minute of CPU time. So it's astonishingly fast. And that means that one could revisit the internals of TeX and ask, what can we do? Take advantage of this tremendous speed, and your own work with TeX as a server is an interesting application of that idea. So if you can typeset a document in a blink of an eye, a document being a typical 10, 20, 30 page piece of text that people deal with in offices, nobody's going to worry about the time it takes. And they'll happily put in a comma and typeset it again.
Yeah. So if, to use your phrase, it will typeset my document in a blink of an eye, using my machine as it is. Well, if I use my machine to typeset the document, but through the web browser, and it's in 3 or 5 or 10 blinks of the eye,
it's still fast.
it's still good enough, particularly as I don't have to install any software, get any permissions or anything else like that. And because I've got, in principle, a fresh copy of the software from wherever it comes from, there's not this, oh, do I have a different version of the software than you do? Well, I've got the same version because I got it from the same place at the same time.
Mhm.
So that shows it's possible, but there's a big problem, which is that our model is that you install a big system, have an enormous meal, and then you typeset from that, from disk. So, and from time to time you update your system. Now, for websites, there are these people that work very, very hard to give a responsive performance. So if you're visiting a web page and it takes 3 seconds to load, you'll lose half your audience, and the other half are annoyed. And essentially, you need 1/10 of a second interaction. Interaction has to be, you have to get a response to what you do within 1/10 of a second to get the appearance of simultaneity. And there are a lot of things that do work like that, even over the network. So the auto suggests that when you type in a search term or something, over the network, that comes back in a fraction of a second. So what's really, really required for every document that you want to typeset in your web browser is a minimal list of what's required. Now, the web people, the web developers, know about this, and their frameworks have tools that do two things. The first is they what's called minify the files. So if there's a identifier that has a very long name, it gets changed to I-37 throughout. So you don't have very long names throughout the place. There are other tricks you can do to reduce the bandwidth required. The functional programming language Elm is very interesting because it has a very, very strong knowledge of what's going on. It can't do complicated logic optimization along the lines of, well, this line of code can't be reached because the Boolean condition is never satisfied. It can't do that sort of thing, but it can trace through all the, so to speak, plausible lines of code and remove everything that doesn't then get executed. It's called shaking the tree. So you start at the root and you see where you can get down, and anything that falls off the tree when you shake it, you don't send. And that produces a great minification. Now, I don't think for TeX we can do that, certainly not at this time, we don't need to, but at least we could shake the tree at the file level and we could say, well, these are the files that were used to typeset this document. Why do we have to send any others? And that produces an enormous reduction in size. And that is part of what I'm up to, is minimizing the size of the stuff that's required. Another way of minimizing things is to use a binary file, which is if you're typesetting a particular document lots and lots of times, why not just have a special format file that contains all the macros? Mm-hmm. And that will have condensed all occurrences of a very long identifier to one occurrence of a very long identifier and umpteen occurrences of I-37. So once you've got that, the first time you typeset a document, it maybe takes a second or two to download all the resources, or the resources you don't already have. And then it takes 3 times as long as normal to typeset it. But you've removed the whole barrier to entry. Mm-hmm. You've completely removed the whole barrier to entry. And moreover, you've removed the dependency on any particular machine. So even if you're in a sort of controlled environment, if you like, you don't have to install TeX on any machine whatsoever. It just gets downloaded into the browser whenever it's needed. You don't have to run it on your own machine. You can just run it on whatever machine happens to be convenient. And the outcome of that would be a something equivalent to what Firefox, Mozilla Foundation and Jupyter are doing, which is a browser-based platform for scientific notebooks, except this would be a browser-based platform for scientific documents that don't contain calculations.
Mm-hmm.
And they're focused on a browser-based framework for scientific I call them notebooks, calculation books that don't contain very much text. So the obvious thing then is to have some sort of meeting of minds and a mixed format that handles both the calculations and the physical appearance of the thing. So you get the best of the typography and you get the best of the interactive notebook. And looking at the social forces, well, if you go back to the Microsoft judgment, Josh Jackson was the name, I think. He identified the problems and I think he made a suggestion to a solution, and then it went up and down the courts and so forth. What he didn't do was say, and Netscape will conquer Microsoft and take over and provide a new platform. He did provide some remedy for Netscape and also some remedy for the community at large. So one of the things that followed was there was an opening of the door in terms of non-Microsoft browsers being used on Microsoft machines. You know, there were these rules about you can't force people, you can't, so to speak, you can't hide you've got to give equal prominence. Equal prominence. We've had the same story with search results where Google stuff gets higher up on the search results. You've got to give it equal prominence. So Judge Jackson didn't say the web browser will become the platform, but he said there'll be some removal of restraints on competitive forces. And those competitive forces gave rise to Google, and Google gave rise to Chrome, and those forces and other forces gave rise to HTML5, and the web browser has become a platform. And it's the forces rather than the particular experience of Netscape that produced that conclusion. And in the same way, I'm saying that it's the forces that will produce TeX Live being available in the web browser as a mainstream process, rather than any particular individuals or groups. And so I'm predicting this not on the basis of a deep understanding and knowledge of the TeX Live community and the TeX users group and all that, but actually on what's going on outside. And the one thing missing from my prediction is that it will be called TeX Live. And in that respect, I'll resort to something that Grace Hopper said, I believe, which is something like she didn't know what programming language would be used in 2020, but she did know it would be called Fortran. Mm-hmm. I suspect that when TeX becomes widely available in the browser, it will become known as TeX Live.